In this video, we're going to solve a problem which appeared in JEE Advance 2019. So in this problem, we need to find out the limit of the n tends to infinity and the given series, right? That 1 cube root of 2, cube root of n up to that, and whatever there in the denominator. Okay. Now here, we need to find the value of a so that the given limit is 54. Now here it's a limit problem, but we need to solve this kind of limit problem using the concept of integrations. The integration or the definite integration with have the finite sum, that limit as a sum of finite sum. Okay, so based on that concept, we need to solve that. So let's go ahead and start solving this particular problem. So first we consider the limit, given limit as L, right? So the algorithm, whatever I thought of, right, is that first we need to calculate the value of the limit L as a function of A, and then we'll equate to 54, and then we'll obtain the value of A. Okay, that's the algo. So here we recall one formula, that summation n tends to infinity, okay, which concentrated on that. Here, summation n tends to infinity, r is equal to a to pn, right? 1 by n and function of r by n. If we get the similar kind of limit, so then it can be expressed as 0 to p fx dx. Now here, what is the value of a, right? Now a can be start with 0 or can be start with 1. There are not a huge difference on that. Now we can say that why so? It's because, right, we first one case we just applying for that right sum, or that another way we just go ahead and start from the second thing onwards. Let's explain that little bit, right? So let's consider that we have a function, right? And we have a graph fx, right? So this is a arbitrary graph fx, right? Now here basically we are dividing it into small rectangles, right? Now the area of the rectangle can be approximated by the side length of left hand this side, or maybe the same rectangle can be approximate the area by the other side, right? Or if we consider as a trapezoid, right, we can go ahead. So basically it's saying that if r equal to 0, may we start with here, or maybe we start with from the next point. Okay, that doesn't mean that sense, right? Why? Because n is infinity, so the difference, right, of the rectangle or the wideness of the rectangle are too small that r equal to 0 to 1, that doesn't mean anything. So both can be used. Okay, let's go ahead. So here first we consider the numerator. Now in the numerator, it is obvious that it can be written as a summation r equal to 1 to n r to the power 1 by 3, or maybe cube root of r. So whatever is useful. So basically I love to use that in that r to the power 1 by 3 form, because the calculation became easier. Let's go ahead. Now we just concentrate on the denominator of it. Now in the denominator, we have a function of n, right? N to the power 7 by 3. So we can use that latter, because if we need to multiply, we can multiply at any time, right? So that's why we just concentrate the terms in the parenthesis in the denominator. Now notice that here it will be 1, 2, and n. So these are the changing variable, and n is constant everywhere. So therefore, in summation form, it can be written as r is equal to 1 to n, 1 by n plus r whole square. So now notice that we are able to write both the terms in summation form. So let's rewrite that L in the terms of this summation notation. So therefore in the numerator, we have summation r equal to 1 to n r to the power 1 by 3, and in the denominator we have summation r equal to 1 to n 1 by n plus r whole square. So these are the expansion, and obviously that n to the power 7 by 3 will come directly. They're not a problem. Now see that here we need to rewrite all our terms in the form of r by n. But here we have r, here we have r. So therefore, we have to take common the appropriate n, so that it will be of the form of n to the power r by n form. So how we write down? Let's concentrate on the numerator. So see that we need r by n. So I just forcefully write r by n whole to the power 1 by 3. So if I write down, I need to multiply n to the power 1 by 3, obviously. And the summation notation is there everywhere. Now let's go ahead. Now here we have n to the power 7 by 3. in the numerator, in the denominator term, I need to take r by n. How it's possible? I have to take n common. So let's see that. So therefore, we have 1 by n taken common. So it will be n square a plus r by n whole square. And we have the summation everywhere, right? That's it. Now, if we take this n square outside, because our summation is r terms, right? So therefore 1 by n square and all that stuff. So therefore if I write, we get it as n to the power 1 by 3 minus 7 by 3. This is 2, so this is plus 2, and summation of r by n whole to the power 1 by 3, and in the denominator we have summation 1 by a plus r by n whole square. So now see that we are able to rewrite the denominator and numerator or the function in the form of r by n. So that's our job. So let's go ahead and notice that. So first we take that n to the power 1 by 3 common, and it just became r by n whole to the power 3. And if I take 1 by n square common, as we already expressed, we get it done. Let's calculate and simplify. If we simplify, right, we get n to the power 1 by 3, 7 by 3 plus 2 multiplied by something which can be easily simplified as the respective form as you've seen in the screen. Why? Because it becomes, if you calculate, it became n to the power 0, and that's gone. Let's go ahead. See that you will get it as 1 by 3. So it will be minus 6 by 3 plus 2, obviously 0, right? That's it. So therefore, we get the L as a summation of this form. So therefore, just compare that. We get a function in the form of f r by n. We get another function in the denominator, which have in the form of f of r by n. But still, we are not able to use the formula whatever it's displaying in the screen. Why? Because we need 1 by n. So therefore it is obvious that to rewrite, I can easily write 1 by n as a multiplier, right? So both sides, if I divide by that or if we multiply by 1 by n, that system will be equivalent. So that's it. So therefore we just go ahead further. We notice that we have, right, that L can be written as in that form, right? Why? Because we already know that limit some x tends to whatever may be fx by gx, that's the property of the limit. It states that it can be easily written as limit x tends to a fx and then limit x tends to a gx. This is a well-known property. So using that, obviously we are able to get the next line. Okay, that's it. Let's go ahead. So now we just introduce, as we say, 1 by n, so that we are able to use the property we are start with. So therefore, we can easily go ahead and rewrite the numerator and the denominator in the form of the integration formula. So here notice that first we concentrate this integration. Sorry, this limit. So here, what is my function? Here my function fx must be equal to x to the power 1 by 3. Why? Because see that f of r by n. So wherever we see r by n, we'll replace by x. So that's why it will be x to the power 1 by 3. In the denominator, right, we have the function. What is the function? It will be a plus x whole square and 1 by. Okay, that's it. So that's the thing. And as it is a limit, we just need to apply that integration sign. Now see here, it is only for n. So therefore, p is equal to 1. So therefore, it will be 0 to 1, 0 to 1. And that's it. Let's go ahead. So therefore, L can be written as integration 0 to 1 x to the power 1 by 3 and 0 to 1 a plus x whole square reciprocal. So that's it. Now we need to find out the integration and we obviously get our limit. So first we consider the limit in the numerator. It is a very straightforward limit. So it will be x to the power 3 by 4, x to the power 4 by 3. How we do that? It is very simple, right? It will be x to the power 1 by 3 plus 1 divided by 1 by 3 plus 1. So therefore it will be 4 by 3, here also 4 by 3. So that's why it will go upstairs, be reciprocated, and x to the power 4 by 3. So that's we directly write it. Applying the limit, we get it as 3 by 4. Go ahead for the next integration. it is 0 to 1 a plus x whole square. If we integrate it, right, we get it as 1 by a minus 1 by a plus 1. That's very, again, normal integration. Let's substitute this integration value in this appropriate position, right? So therefore, before going ahead, let's simplify that little bit and we get it as 1 by a into a plus 1. Let's substitute in the respective position and rewrite the integration form, right? Rewrite the limit as a function of a, whatever we start with. So we obtain that n is equal to 3 by 4 a into a plus 1. Now it is given that this particular limit is equal to 54. So now equate it with 54 as we said. Now we can notice that if I multiply, right, 54 into 4 divided by 3, we get it 72. So therefore a into a plus 1, 72, multiply and perform the basic arithmetic calculation to get a quadratic equation. Do the middle term factorization to get the value of a as minus 9 and 8. But notice that here mod a is greater than 1. Hence, both the value are the accepted value, right? Because mod a greater than 1 means that a is greater than 1 or maybe less than minus 1, right? That's the interpretation of mod a is greater than 1. So it's imply that a must be greater than 1 or maybe a less than minus 1. So union of this field, right? So therefore, if it is 0, this is 1, this is minus 1. Any value of greater than 1, less than 1 need to be accepted. So here notice that minus 9 in the accepted region, 8 is in the accepted region. So therefore, in this particular problem, option C and option D are the correct answer. And that's it. Hope you understood the problem. So this is us for this particular video. So please like, subscribe and comment, because so that we can understand that our videos are actually helpful for you. And anything you want to say, or if there is any comment, okay, or any problem, right, which you need to learn through our effort or through from our site, right, please paste it in our link, right, as a link or as a word file, whatever you want. There is an email id is also provided, so please go through that. Okay, so then we will give you the solution as soon as possible. Okay, so stay with us and keep learning and spend a very, very happy journey to your new career or new learning process. Thank you.